Assalamu alaikum guys, welcome to this one, and in this one I'll be covering what are integers inside the computer memory. I mean, you guys know what integers are. I'm just here to explain how they're stored in your computer memory and how you deal with the negative numbers and all of that. Okay, so integers, as we all know, are whole numbers that can have positive as well as negative values. So talking of positive numbers, if you just want to store the positive numbers in a computer's memory, it's very straightforward, and it is also known as the unsigned numbers. In the C language, you can declare unsigned integers as unsigned int a and unsigned character a and so on, and these are very simple. You just store the binary of the number you want to store. I mean, if you want to store a 2, you store a 0 1 0. I mean, I'm showing you guys 3 bits, and in this tutorial we're going to be working with 3 bits and 4 bits, but these concepts are extendable to 64 and 32 bits as well. Okay, so you just simply store the binary of the number if you're not concerned with the sign of the number, and that is why it's called the unsigned numbers. Now let's move on to the negative and the positive integers. I mean, can you build a data type in which you can have positive and negative values? So the first attempt ever made to store positive and negative values just by a single representation in a computer is known as a signed magnitude approach. In the signed magnitude approach, what they did is they said that the most significant bit of the number is going to represent its sign, and the remaining numbers will be representing its magnitude. So if the first bit is 0, the number is positive, and if the first bit is 1, the number is negative. So here you can see we have a number. Its first bit is 0, so this is positive, and its magnitude is 1, so this is positive 1. Similarly, this is positive 2, and similarly this is positive 3, and so on. We have negative 1 and negative 2 and negative 3, but the problem which you might have guessed by now is that we have 2 zeros, a negative 0 and a positive 0. So this was actually why the sign magnitude was dropped. Well, not actually, this was not actually why it was dropped. It was actually complex to implement it inside the computer hardware. There are issues when you're designing the hardware. Okay, so they moved on to something known as the ones complement. Now the ones complement actually takes this simple range. Okay, so we're talking 3 bits here, so our range is from 0 0 0 to 1 1 1, and what it does is it says the numbers with their first bit 1 are all negatives, and the numbers with their first bit 0 are all positives, and we can rearrange them like so to give you guys a better idea. So here we have 0, and this is 1, and this is 2, and this is 3, and here we have negative 0. Yes, ones complement also has a negative 0. We have negative 1, negative 2, and negative 3. And the great thing about ones complement is that if you have a number, let's say you have 2, which is 0 1 0, if you want to go to negative 2, you just have to invert all of its bits. So negative 2 would be 1 0 1, and which you can see right over here. So why this helps, let me show you an example. So let's quickly say I want to subtract 3 from 4. Okay, I can rewrite it as 4 plus negative 3. Now you must keep this trick in mind, alright, because this is the most important trick when it comes to subtracting numbers using digital logic. Okay, so let's write this down in binary. I have 0 0 0 1 0 0, this is 4, minus 3, which is 0 0 1 1, and I can rewrite it as 4 0 1 0 0 plus the negative of 3. Now how would I represent the negative of 3? 3 is 0 1 1 and the negative of 3 is 1 0 0. Alright, in 3 bits, but in 4 bits it's going to be 1 1 0 0 because you just negate all of the bits. So let's try adding these. 0 1 0 0 plus 1 0 0. So 0 plus 0 gives me a 0 and 0 plus 0 gives me another 0. 1 plus 1 gives me a 1 0. So I take the 1 to the next place and I write the 0 over here, and this is 1 plus 0 plus 1, which is 0 1 again. So this becomes 0 1. Now the problem here is that we are working 1 0. So the problem here is that we're working with 4 bits, but we have an additional carry at the end. This is actually known as the end around borrow, and the way to fix it is that you add it to your result. So our result is 4 zeros and we have an end around carry, unfortunately, so we're going to add it to this result, and this actually corrects the answer. So this is 4 and this is the negative of 3. If we add them up, we get a 1, and this is actually how a subtraction is done in the ones complement. But now let's move on to something much more manageable, which is the 2's complement number system. Now the 2's complement number system works similar to that of 1's complement, but in 1's complement, let me just take this and paste it over here so you guys can compare the two. Okay, so in 1's complement we have 2 zeros, this one and this one. 2's complement says okay, let's not do that. Let's just say okay, this is 0 1 2 and 3, but let's not say this is negative 0. Let's say this is negative 1 negative 2 negative 3 and negative 4. So now if you want to convert a number which is, let's say, 2, if you want to convert it to its negative counterpart, you invert the bits just like in 1's complement and you add a 1 to it. Alright, so you take 0 1 0, invert it 1 0 1 and add a 1 to it, 1 1 0, you get negative 2. Alright, so we're going to use the same trick over here. 4 minus 3, 4 plus the negative of 3, so this is 4 and this is 3. Now you take the 2's complement of 3 to get negative 3. 2's complement of 3 is actually it's 1's complement, which is 1 1 0 0, and we add a 1 to it to get the 2's complement, which is 1 1 0 1. So here it is, and we're adding it, we're just simply adding it. So this is 4 and this is negative 3, and we add them. 0 1 gives me a 1, 0 0 gives me a 0, 1 1 gives me a 1 0, and 1 0 1 gives me a 1 and a 0. So a 1 flies at the end, but you don't actually have to worry about it because you can totally ignore it, and that is the advantage in the 2's complement. Your arithmetic in hardware becomes easy and you get rid of the negative 0. Alright, so I guess you guys understand this because it is kind of important, and if you have any questions you can inbox me or you can just catch me and ask me about it. Okay, so thank you guys, thanks for watching.